Good afternoon, everyone. Welcome to CPA's educational session. Today, the CPA, the Association for Contract Packagers and Contract Manufacturers, is pleased to present Designing for the Future, Creating Recycle-Ready Packaging. I am Michael Collins, Vice President of the Contract Packaging Association. Before we get started, I'll give you a short overview of the CPA. We've been promoting the growth and welfare of members through industry exposure and networking programs since 1992. CPA members are comprised of the nation's leading contract packagers and contract manufacturers who perform all types of manufacturing and packaging functions for brands and CPGs. The Contract Packaging Association serves as the connection point for the industry through continuing education, market knowledge, and customer relationships. One of the key components of our mission is education. Today's session is an ongoing commitment to inform the industry on innovation. While members join the CPA for many reasons, by far the greatest benefit received is the networking with users of contract packaging services, suppliers to the industry, and other members. We are collaborating with the Chicagoland Food and Beverage Network on a regional meeting in Chicago on June 13th. It will be hosted by Frayne Industries at their headquarters in Carroll Stream, Illinois. We will also be at Newtopia Now in Denver, Colorado on August 27th and 28th. Booth number is not assigned yet, but will be determined shortly. In addition, if you are attending Pack Expo International in November in Chicago, please stop by our booth in the North Tower, booth number 4511. And remember, there is a social networking session on Monday, November 4th at our booth starting at 3 p.m. Also like to point out Engage. Engage is CPA's annual event in February. In 2025, this event, the premier gathering for the industry, will be held in Clearwater, Florida from February 4th to February 6th. You are all invited, and additional information is available on the CPA website, www.contractpackaging.org. Before we get started, just a few housekeeping items. All attendees are in mute mode. At the end of today's session, a brief survey will come your way. Please provide us with feedback. It is very important. In addition, the entire webinar is being recorded. Within 24 hours, an email will provide you with a link to the recorded session. During this webinar, there is a Q&A box at the bottom of the screen. We invite attendees to submit questions via the Q&A function on your toolbar. So let's get started. Today's presenters are Eduardo Ruiz, Principal TS&D Scientist from Dow Packaging and Specialty Plastics, and Michelle Sauter, Marketing Director, Dow Food and Specialty Packaging. Each of our panelists will offer a brief overview of their background experience to get us started. Michelle, over to you.
Well, thank you, Michael, and the CPA for hosting this today. This is a topic that is near and dear to Eduardo and I, and so we're really excited to share our perspective on design for recyclability and some of the work and effort that we have been putting in over the past maybe 5 to 10 years to make it a reality. My name, again, is Michelle Sauter, and I have responsibility for Dow's food and specialty packaging business in North America. If you're not familiar with Dow, we make polyethylene products and ethylene copolymer products and sell those across a variety of market segments, including packaging. I've been in packaging for about 10 years. I worked for Dow for 6 years, and I worked for DuPont for 16 years before that. Eduardo, you want to introduce yourself?
Yes, thank you, Michelle, and thank you, CPA, for having us today. Thank you also for attending. My name is Eduardo Ruiz. I'm a principal TS&D scientist based on our Dow Pack Studios in Freeport, Texas. I have been in Dow for 24 years, servicing the packaging, flexible packaging market together with our team globally. And it's our pleasure to be here today.
Thanks, Eduardo. Let's get started. From an agenda perspective, we wanted to share from a market driver trend why recyclability is important and what makes a package recyclable. And then Eduardo will take us through some examples and case studies of the work that we've been doing to enable the shift to all PE monomaterial recyclable packaging. So we'll start at the beginning of why is recyclability important. There is a lot of consumer research that's out there. Shelton Group, you may be familiar with, they do a lot of really interesting consumer analysis, trying to understand the top trends and things that are on consumer minds and kind of where the market might be leading. And their Recycling Pulse or Eco Pulse study is something that they do every year and report back out about what's changing and what's new from a consumer mindset and what they're thinking. So this is one that they did in 2022. And because of the messaging from the industry, I mean, we have really done a good job of helping consumers recognize that recycling is good for the environment and that it's the right thing to do going forward. I know there's a lot of maybe negative information out there about plastics. And a lot of that is surrounding the fact that we need to find ways to keep it out of the landfill and maybe more importantly, just keep it out of the environment. And that's why recycling is so important. And consumers really see that as a way that they can be more environmentally friendly. Next slide. And as we all know, you have to follow where your customers are leading. And so as consumers are saying, I need packaging to be recyclable, that's really driving the global brands and the sustainability goals. So this is just a high-level snapshot of a handful of brand owners from across various markets and applications, the retailers, as well as some of our customers, the converters who make the films. And suffice it to say, increasing recyclability is a very common focus area, PCR incorporation, down gauging. I mean, there's multiple ways that you can enable a more sustainable future. I don't see those as either or. It's sort of like we need all of these different solutions to really make a difference on the environmental impact and to stop or end plastic waste. Next slide. I hope many of you are familiar with the Ellen MacArthur Foundation, which is a body that has signatories. A lot of them are brand owners who report on the progress that they're making towards the goals. They have more than one goal, but the goal that I pulled out here is relevant to our conversation today about how do we ensure that 100% of plastic packaging is reusable, recyclable, or compostable. And there is this goal out there. Most companies have the goal of getting to 100%. And you can see that a little bit of progress has been made, but certainly not as much as we would hope. And that's part of why we wanted to have this conversation with this team and this set of experts so we can understand your challenges and figure out ways that we can address those going forward. Next slide. One of the important things that is evolving in the recyclability and sustainability space really is the legislation piece. California SB 54 is probably one that I'm watching most closely because it is starting to set some expectations and standards around plastic and what the guidelines and regulations are going to drive going forward. So if you're not familiar with that bill, I recommend you either reach out to me or do some research on your own. Extended producer responsibility is important. And from a Dow perspective, we absolutely support this. So extended producer responsibility is really that a brand owner is going to have to pay a fee based on a schedule that's yet to be determined for each of the packages that they sell into a state. There have been at least 4 states that have announced these EPR fees that will be going into effect. They have different effective dates and timelines that they're working against, but it's really important from a Dow perspective that they get in place and that they're fair, flexible, and address the problem. So we're excited about having this come forward because we feel like it will be an important driver to help accelerate the move to recyclable films. And at the same time, we need to have the money to invest in the collection and sortation and other pieces of that ecosystem that need to be developed. I mean, I could spend all day just on this topic, but just wanted to touch on this briefly, and we can go to the next slide. So we talked about why are we worried about recyclability. We talked about the brand owner goals, and to share kind of where we sit and Dow's strategy and perspective, we also announced our own sustainability goals, which are listed here. At a high level, we talk about closing the loop, which is our 100% recyclable or reusable goal. This is really where circularity starts. It starts with designing the materials so that they can be collected and they can be converted into a high value, high quality PCR stream. That's connected directly to our Transform the Waste goal, which is our commitment to deliver 3 million metric tons per year of circular and renewable solutions. So that encompasses our activities on mechanical recycling, advanced recycling, as well as renewable feedstocks, which are from biosources to replace fossil fuel-based plastics. And then last but not least is protect the climate. I have to tell you that it's been really interesting to me to see the shift from sustainability was being measured by recyclability and how quickly sustainability is going to be measured by carbon. So we're not quite there yet. I think there's a lot of development and education that will have to happen both at the brand level as well as consumer level to understand carbon footprint and the impacts of our choices. But I definitely see that as an emerging trend and focus area that we'll have to figure out in the next 3 to 5 years. Next slide. Okay, now we're talking a little bit more down into the nitty gritty here of what makes a package recyclable. Okay, I don't know how many of you are familiar with APR, but they have a very clear guideline of how you define recyclability. And it's really made up of these 3 bubbles. So there's one, is there a way to collect, sort, and handle a material? Is it reprocessable into something that can be used again? And then are there valuable end markets that the PCR products can go into? And you need all 3 of these to have something that's considered recyclable. Polyethylene-based films are the preferred material of choice. So when we talk about mono material, we're talking about polyethylene-based options, which is what Dow makes and sells. And the reason why polyethylene is preferred is because the store drop-off program is the only widespread collection method that's available for packaging films. And the APR guidelines focus on films that are greater than 90% polyethylene. You can create other monomaterial films from other things. The point is that there's no collection method for that. And so that's one reason why polyethylene is preferred. Secondly, can you reprocess it? Yes. I mean, the APR represents mechanical recyclers, for example, who can take the store drop-off collection and they can turn that back into a pellet or a PCR product that can be incorporated back into films or other applications, depending on the quality of the material. And then lastly, are there valuable end markets? So this is a study that it's a little bit outdated, but I think it still represents today. Where do those collected PCR, where does that go to? And decking is a big one and will continue to be a big one. And it makes the economics work. You need to have a way and end markets that are valuable enough to buy the PCR and make the economics of recycling meaningful. Next slide. So this is getting more into how we work with and how the value chain works with the various organizations that have been established to help us define recyclability. And this is mainly focused on mechanical recycling. If there are questions about design for advanced recycling, we can take those offline or you can reach out directly. So we're going to speak more specifically on mechanical recycling today. So it starts with the Association for Plastics Recyclers. Dow has a member. We have multiple people really that participate with the Association of Plastics Recyclers, and they represent the mechanical recycling companies. And so their goal is to create test protocols to determine if a package can be recycled, sorted, and cleaned through their participating members. They have something called the design guide. You may hear it referred to as that, or critical guidance. And you can go to their website. We put some links in here that you can go and you can review the design guide to see what's accepted, what's not accepted. And our customers, and we use that a lot to help make sure that we've got the right products to support the move to recyclable films. Once you've quote unquote passed or met the design guide as best as you think possible, that then gets passed on to the Sustainable Packaging Coalition. So a converter makes the film. If they need to, they might do some additional testing through APR, and then the brand owner takes their final packaging structure and whatever is in there, whether it's pet food or granola or you pick your favorite, that goes to the Sustainable Packaging Coalition. The Sustainable Packaging Coalition is material agnostic, so they don't focus only on plastics. They will take any package material, and they look at it more holistically in what's in the package. Are there contaminants to the film that I need to be thinking about? Will any of the structure or the contents affect the ability for it to be sorted or to be turned into a PCR product that can be used later on? So they kind of look at the package and the contents to decide, does it meet, or which standards does it meet, and therefore what label should it be given? So if you're successful, or the brand owner is successful with this, the Sustainable Packaging Coalition will issue the correct how to recycle label that the brand owner can then put on the package when it's printed and shipped to the stores. The one that you see at the top there where it says recycle if clean and dry, that's the symbol that you're looking for store drop off. That means that it's compliant and can go into the front of the grocery store or the Targets or the Walmart or wherever you shop. But there are other alternatives depending on, again, the contents and the package itself. It might say check locally, or it might say, for example, on a cereal box, it will have the box can be recycled curbside because it's cardboard or paper. And then for the most part, the cereal liners are recyclable, and it will give you instructions for how to separate those things and put them in the right streams. Next slide. So this is maybe just to bring it down to the next level of how APR and SPC define what's accepted and what's not. The APR, as you dig into their design guidelines, they will have, I guess, these categories where, is it recycling preferred? Is it recyclable with detrimental features? It needs testing, etc. And then on the right-hand side, you can see this letter. So one thing that Dow proactively does is if there's a product that we make that can either support recyclability, and Eduardo will talk about an example with Retain where we've worked with APR to get that approved to compatibilize EVOH and nylon structures so they can be accepted by mechanical recyclers. Or sometimes we have products like Surlyn that they're polyethylene based, but they have some unique functionality or chemistry. And so we proactively work with APR to go through the testing to show that they can be used and incorporated into recyclable films. And then, as I mentioned, SPC takes a broader look at what's in the package. Can it be collected? I didn't mention that in order for something to be considered fully or widely recyclable, it has to have, the population has to have access, 60% of the population has to have access to a collection method. The store drop-off method is widely available, and so that's how polyethylene-based packages can have the widely recyclable. We're working hard on curbside collection as well, and see that as the long-term preferred method. But for now, I highly recommend, if you don't already, to do store drop-off, and I see it as a way to keep plastic out of the landfill today, and also it helps supply the PCR that we all are interested in incorporating into our packages at the end of the day. Next slide. All right, this is, every time I go to the grocery store, my kids always are complaining like, Mom, I don't want another picture of me recycling, but it does start with the next and upcoming generation. So those are my kiddos being forced to recycle. And this is my local grocery store of what the bins look like. If you're wondering about store drop-off in your region or your state, there's a link here that you can go to. They can accept and do accept things much more broadly than just the plastic grocery bags that we are very familiar with. They'll take air pillows from e-commerce. They'll many like shrink, depending on, like, for water, depending on what it's made of. Many of those will have the how to recycle label, and they're clean and dry. And so they will also be accepted to store drop off. So I encourage you, I mentioned cereal bags. So I encourage you to take a look at your packaging and do your part and do this. And then you can share your pictures in the grocery store recycling. And with that, I will turn it over to Eduardo to get into more specifics.
Thank you, Michelle. Okay, let's start with an overview of the challenges to develop recycled flexible packaging and the concept of the design for recyclability that Michelle mentioned. So when we have to design a packaging for certain product application, we need to consider the key performance requirements. We need to understand shelf life, barriers, oxygen, moisture, light, flavor, taste and odor, shelf appeal, dermaticity, and all the functionalities we have in packaging today, like easy opening, etc. As you can see in the illustration on the left, in most cases, this properties combination only can be achieved through a multi-layer film composition and the use of dissimilar materials that are difficult to recycle. Here to the right, we have two typical examples of non-recyclable film today that you use in the industry. For example, the first one here on the left, this is a PET printed web laminated to a PE sealant for low oxygen barrier applications. This today is used for detergent powder, dry food, pet food, etc. And to the far right here, we have another structure also with a PET printed web laminated to a PE EVOA high barrier sealant web that with a higher oxygen transmission rate barrier that is used, for example, for meat and cheese. So over the years, our industries has developed and optimized film structures, packaging designs, and equipment to deliver these performance requirements and functionalities. Sustainability and end of life now became one of the main requirements for our industry. Our challenge now as an industry is to how we can deliver competitive cost performance packaging considered the end of the life. When we are designing now a packaging, we should look into several aspects, as I show you here. You start here on the left at the shelf life and film barrier requirements. Then we talk about machinability, is how you making the bag, the film and bag making process. So the stiffness of the film, the sealability, dermaticity. Then you have the packaging performance itself. When you're taking the packaging from the, when you fabricate it all the way to the shelf. So abuse, transportation. So you gotta have the physical properties for the packaging. And then finally, when it gets to the consumer and he's in the point of sale. So the consumer appeal, the surface, the aesthetics, the stiffness, the transparency, and very important, like I said, is the end of life. And we were talking today about recyclability, but Michelle also said that we are designing also for advanced recycling. This is what we call now design for recyclability. We need to take all this in consideration, and very specifically, we need to consider the end of the life. So let's talk about the challenges we have to convert multi-material like we have today. A lot of materials there's similar. How you convert this to monomaterial? So the first challenge is barrier. So the first thing, as you can see here, we have different type of products that we need. They have different shelf life requirements and barrier requirements. And as you can see on the bottom here, monomaterial like polyethylene and polypro, they have a relatively low oxygen transmission barrier or water vapor barrier. And as you go to some applications here, you need to go with the structures that have a higher barrier, like metallized structures, EVOH, PVDC. So the big effort we have as an industry today is how can we make monomaterials like polyethylene, how can we improve barrier of those monomaterial films? And that's the work the industry is doing, especially ourselves. Like Michelle mentioned about, we have developed what we call compatibilizers for polyethylene and in resins like EVOH and nylon. So we have today our retain that is used to compatibilize, and we got the approval from APR that we can use up to 15% EVOH with retain, and this material passed the requirements for APR. So we can, in this case, expand the use of monomaterial to applications that require more barrier. And also the industry continues to try to improve that levels of barrier. There's a lot of work being done in the industry with the metallization of polyethylene, etc. So this is the first challenging, but we are working on it, and we are bringing technology to allow to expand the use of monomaterial like polyethylene with a higher barrier. The other aspect is related to how we build the structures today. So basically, we have what we call a print web that we're going to laminate it to a sealant web. And those print webs are typical BOPP, polyester, nylon, and they have some characteristics that make them very valuable for the packaging today. And we're talking about high gloss, high stiffness, high heat resistance. So that's the challenge we have. So what I exemplify here in the two graphs to the right is when we go to the monomaterial, the challenge we have is that polyethylene by itself is the stiffness is not comparable today as a polyester or a nylon or polypro. That's one of the challenges, how we can bring the stiffness to the package that is needed, especially for the bagging making process. And the other one is the thermal resistance of polyethylene that you can see here. The higher density goes all the way to 130 C, but other materials like polyester, nylon, they melt with higher temperature, so they give more thermal resistance that is very beneficial for the bagging making process. But how we are tackling, how we are developing technology to overcome those challenges. So, and that's what we call about the D4R concept. The design for recyclability concept refers to replacing non-recyclable resins, such as polyester, BOPP, for example, with polyethylene resins, so they can comply with APR guidance. They can qualify for SPC labeling, like Michelle mentioned, and they can be accepted and stored or proof. As we discussed, this process is involving the collaboration of the entire packaging value chain, starting with us, raw material suppliers, film suppliers, converters, packaging OEMs, co-packers, that's why we're here today, and brand owners. So the flexible packaging industries is working to develop new technology to improve monomaterial performance for recycle ready. We are working on new resin development. We are working in new film technology orientation that we're going to cover in a minute. And the packaging OEMs are working on optimize their equipment as well. So starting with the resin development, like Michelle said, we've been working and developing and bringing new resins, new materials that can enable to close the gap that we have, that we just mentioned about barrier, thermal resistance, and stiffness. An example here, we have this higher density, high moisture barrier, LEED 900. We have developed this compatibilization technology with retain that allows you to add some EVOH in your formulation and still meet the requirements for recyclability. We have our affinity high performance sealants that seal at very low temperature and helps to maintain high speed and achieve hermetic seals. We've been developing high performance, high toughness products like our Innate family. We've been working on overprint finish to help with increase the thermal resistance of the packaging. So this is the effort we have on our end, listening to our customers and the market to understand how can we close that gap, and we're bringing this technology forward. The other one I mentioned is another example is the film development. We have this oriented film technology such as MDO and BOPE to help to close some of the gap of the standard PE film. Both MDO and BOPE technologies offer improved stiffness and optics, and they are developed to replace polyester and BOPP as a print web initially. That's the main for the standard laminated. Both type of films are now becoming commercial. They're available. So the industry is bringing this forward to the market. So, and we are as raw material suppliers working in developing resins and grades for this to process MDO. We're developing and offering polyethylene resins for MDO and BOP. There's a lot of effort and a lot of investments from our industry and film producers and converters in this type of technology. They're acquiring new lines to bring this technology to the market. In our case, we just start up in Pack Studios in Freeport, Texas, inline MDO unit in our WNH line. And this will support our customers and industry to further improve this technology. So this is just coming back to the example I gave in the beginning. All this combination of a new resin, new film technology that is allowing our customers to take what we have here, a non-recyclable structure, and bring them to a recyclable that can meet the requirements for recyclability. So this is an evolving process. So there's a lot of challenge in there, and we've been working diligent with the industry to being able to overcome those challenges in the industry. In summary, we have been working in development of a new PE resins, special resins, and film technology to improve performance of monomaterials to address those challenges the main challenge that I just covered. So now let's move it to the other aspect of the challenges for the monomaterial is what we call machinability, or the filming bagging conversion. So different packaging type, formats, and equipment were traditionally designed to run higher stiff and high thermal resistant materials, like we stated in the beginning. So the relative low modulus and low melting point of PE monomaterial, you potentially affect the machinability. Basically, you narrow the process window. I have here some figures that show the different type of packaging converting system, from the pre-made pouch to a horizontal forming finish seal, vertical seal, flow wrap. So the OEMs, the package OEMs, are working to have equipments that can work with both multi-materials and monomaterial films. That's the challenge that we took as an industry, and we've been moving forward with this. Specifically about machinability, the main issue we have is, like I mentioned, on the machine side, is basically the film integrity during the bagging making process, tension, friction, the heat sealing, and how can we get a very broad packaging window that gives you, the packaging speeds that we are used to have with hermetic packaging. So traditionally, if you don't work the way we've been working to optimize film structures and machines, so you end up having polyethylene has the tendency to, because of the characteristics we just mentioned, to eventually to melt, stick to the bar, to shrink. So that would turn to poor packaging productivity. So that would be a narrow package window. We have to run at low speed, so have more pouch failure. So that's going to impact our cost. So basically, with the combination of improving the film design and optimizing the equipment is allowing us to close those gaps as we advance. So here, just to summarize here, package OEMs are upgrading new equipment and retrofitting existing. So in some cases, the machines that are coming to the market already have that technology to run monomaterial and multi-material incorporated, but some existing equipments, eventually you need to do some retrofitting. And basically, we're dealing with tension control, cooling, additional seal station, as we cannot seal at the same high temperature that we seal with the multi-material. So basically, we need to have more seal stations to help to seal and guarantee we have hermeticity. I just show here in the left bottom, the corner here, standard pouch where you have what we call the triple point, where you have two plies with the 4 plies together, and we tend to have, if you don't seal properly, you tend to have a leak area. So that's why adding a triple point sealer or an extra seal station, you help to close that. And here to the bottom right, I have an example. There's some data we generate in the lab that you using a extra seal bar, a triple point sealer with the right material, you can broaden up and have a decent packaging window, processing window in the equipment. So basically, the combination of the like I said, the film development and optimization of the equipment are allowing the converters and brand owners to operate with improved productivity. So we still need to make an assessment on type of equipment, film structure is case by case. So as we progress, we're learning more, we're bringing more solutions, and we are advancing. So here another two, I'm going to cover some another example. Here's we're talking about a spout. So when you have pouches with a spout, so traditionally in a multi-material, you seal at a higher temperature, like 190 to 100 degrees Celsius. But when you go to mono-material, like a polyethylene-based film, so you're limited to 130 degrees. So that limits, the amount of heat you can do there. So basically, this slide here show how we are getting together as a value chain and working on the film, working on the spout design, working on the spout material, working on equipment to make this a more robust solution like we used to have with multi-materials. That's an ongoing effort, and is paying off all the effort. So here's, for example, technology that we developed with our partners. One solution to help to insert the spout, we're preheating the spout before we insert it to the pouch. That's a way for us to kind of close that gap between the lower temperature we can apply into the polyethylene film. So those are examples that I want to share with you that how our industry is tackling those challenges. And again, this is what we are doing to develop, to bring new technology, but we need to, there's a lot of efforts that are in place to make sure that recycle-ready structures are being introduced to the market. We have been collaborating with film producers, converters, brand owners to validate new packaging performance. But as you know, I mean, as you move into the mono material, so some projects can take several months from initial design to commercialization, as we need to go over all the steps for the qualification of the new packaging, from the shelf life itself, from the abuse testing that you need to do in the packaging, even for the transportation. So it's a lot of effort from our industry to convert, not only to develop technology, but then to implement commercially. So it takes the whole value chain, and that's why we're making this effort. Just to finish up on my side here, this is ongoing. I mean, we've been working on this technology, like Michelle said in the beginning, for more than 5-10 years, in fact, that we've been working. This is an example of where we're able to take a non-recyclable pouch for granola that was a barrier material, and we were able to convert to a mono material, and we are achieving the barrier. You see in the bottom here that these structures allow us to get the properties, the barrier shelf life needed. As well, we work with the OEM, the package OEM, to make sure we could run this film structure at the productivity that is needed to make cost effective. And there are many other examples. I mean, this is an ongoing effort to the whole industry, not only North America, but also globally. So we have several examples of products being converted from multi-material to mono-material in different applications. When you have the technology, we have all the barrier needed, etc. Here, I'll suggest you, when next time you go to the supermarket, and I do that all the time, is look for products that have already been converted to recycle ready, and looking for the how to recycle label. So here are some examples of markets or applications that been lately converted to mono material: dishwash pads, dry food, sugar, salt, flour, granola, cereal bars, pet food, etc. So, and more coming. With that, I turn back to you, Michelle.
Thank you, Eduardo. So I'm going to ask for any questions, because I feel like all the webinars that I attend, I get the most out of the Q&A part. So please, if you haven't already, submit questions so we can have a good discussion at the end. I think the main takeaway today is that recycle-ready films are here, and packaging equipment to be able to process those and make a stand-up pouch or other formats, it is available. I mean, to be honest with you, it's evolving. You probably know that well if you've tried to run a recyclable film in your facility. One thing that I try to keep perspective on is that packaging has been around for a long time, and it has been optimized over many, many decades. And the way that it has been designed and optimized, it was really around cost and doing, performing the functions of packaging at the most optimized cost. And sustainability is maybe, has thrown a curveball to us all, and it has happened relatively quickly in the grand scheme of things. So we're early in that optimization journey, I'll say. We absolutely believe that through partnership with the value chain that we can get back to the same level of efficiency with things like MDO or BOPE or optimizing the temperature gap to improve machinability. It's just going to take us some time. And that's really why we're here, is to say that we need your help, and we need the whole value chain to really work together to understand, one, what are the latest and greatest gaps out there from a performance standpoint, and how can Dow and our direct customers and your suppliers of film and the brand owners that you sell to, how can we work together to address whatever those challenges are, so that we can increase and accelerate the adoption of recycle ready films. So I guess that's the ask for today. And I have a couple of closing slides, so you can go to the next one. So we wanted to just put, this is very high level. And as Eduardo was mentioning, packaging is a complex landscape, right? There's different types of food, there's different packaging formats. Stand-up pouches has been an area where there's been a lot of success in moving to a recyclable film, and they can also be collected by store drop-off for the most part, assuming that the contents are clean and dry. So what we're focusing on now is like, what's after stand-up pouches, or what's the next challenge that we need to work on it and figure out the best solutions for flow wrap or for stick packs or for whatever is top of mind for you. We would love to understand, where are you seeing the biggest challenges? What are those challenges? And then, what would be needed from a collaborations perspective to move them over the finish line. Your packaging equipment does matter. We have used Pack Studios as much as possible to try to understand what sealants work best and how do I optimize the sealant so that hopefully you can run that with existing seal bars. That's not always possible, just in transparency. There are OEMs who have upgraded seal bars and can help to optimize that process. But again, we're at the fairly early part of this journey. And so we've got more work. And really, it's an opportunity, right, to figure out how do we optimize and get line speeds for monomaterial recyclable films at the same level as the incumbent. We talked a little bit about APR and SPC. There's a lot of details there. What Dow has been working on is understanding these products or resins like nylon or EVOH that have a negative impact on the recycle stream, and what we can do from a technology or chemistry perspective to address those so that more films can be recyclable and can be collected to feed the hungry beast that is PCR. And then know who to call for help. Like I said, value chain effort is needed here. Not any one part of the value chain has all of the information. And so that's why I think it's so important for us to raise the gaps and have a cross value chain collaboration to try to figure out what we're going to do differently to address them. Next slide. Eduardo mentioned Pack Studios, and this is just a quick highlight of what that looks like. This is the North America one that you see in the upper left-hand side. That's really the building. It's so big because we have a commercial scale WNH 9-layer line that's part of that. And we recently installed an MDO line. So we are working hard on how do you not only have the right resins, but combine those with the right technologies like MDO to maximize the performance and minimize the differences between the recyclable structure and the incumbent. We also, in addition to film production, we have a wide variety of packaging production. So we have a mess pack line, we have thermoformers, and then we also have capabilities to do transportation testing. One of the other areas that we participate are in shrink and stretch and whatnot. So that's kind of a one-stop shop. We like to call Pack Studios our packaging playground, where our customers and partners can come and run trials without having to break into their own lines, which can be very difficult. And so this is just a better view of all the different pieces that make up Pack Studios. We've got smart folks like Eduardo who are really making this happen behind the scenes and have been in packaging for a long time and lend their expertise to help us make progress and support developments in this area. And with that, I will open it up for questions. And I know sometimes it can be hard to ask questions in a forum like this. So you have our contact information here. We would love to hear from you, and or connect up with us on LinkedIn if that's an easier route as well. So I'll pause and see if we have any questions.
Wow, thank you so much, Michelle and Eduardo, and Dow as well, for affording you the time to provide this fantastic information on a super hot topic. We do have a few minutes left, so we will jump into a few questions. This particular question is not directed at either one of you in particular, so I'll let whomever jump in feels the most fit. The question is there any further guidance on adhesives used in packaging, ? Like PE tapes with adhesives?
Well, I will provide my perspective, and Eduardo, you can add. So adhesives can be made up of a variety of chemistries. The adhesives that we sell, like laminating adhesives that we sell, if you go to APR critical guidance, we've gotten some of those approved for use in packaging, but it really depends on the specific product and what that chemistry is. So I'm not an expert on adhesives by any means. So I don't know that I can specifically answer that, but if you want to reach out and send some more specifics about the type of adhesive that you're using, we can certainly bring that to our internal experts to try to get you some clarity on the question.
Yeah, and my suggestion is also, I mean, APR has a lot of resources. I mean, if you go to the APR website, I mean, they have, for the different materials, the guidelines, etc., not only for polyethylene, but for a variety of material. But we are open also to kind of try to direct you to the direction you need.
Okay. Moving right along to the next question. In today's market, can you give some examples of packaging applications that can be converted to mono material?
Yep. So as Eduardo mentioned, stand-up pouch is a format. I can use some other examples. We've been doing a ton of work on nylon replacement or minimization, because nylon can be a contaminant in the mechanical recycling stream. Nylon's used a lot in things like thermoforming films, liquid packaging, and some other formats. So thermoform films would be an area that we've been working a lot on optimizing the formulations to enable those to be recyclable. I mentioned stick packs. We had an announcement in Europe where we were able to take something that's a metallized stick pack and come up with a way to make that recyclable using MDO and some other technologies. We've been working on solutions for like a PVC overwrap. So really anywhere where there's these non-preferred materials, we've been working on the solutions that would enable them to be able to move. And another example would be toothpaste tubes. So it's a little bit of everything. I think we've started with the things that maybe because they're clean and dry can be accepted to store drop off. And with time, we're now moving into those higher performance, higher barrier, more difficult areas and looking for the right solutions to enable them to be recyclable. Eduardo, anything else from your side?
No, I would say like dry food, where we have already technology fully validated, etc. Dry food, frozen food. So those can be converted to monomaterial. And then we've been expanding this to applications that need more barrier, like you exemplify. You have success case in Colombia recently on cloth packaging, converted to monomaterial. So there's a lot going on and several opportunities out there. I mean, but definitely their products are ready and can be converted right now, but the technology is full available.
Excellent. Thank you so much. Next question. What are the main challenges you've seen slowing the progress towards recyclable structures?
Okay, this is near and dear to my heart. I spent a lot of time on this one. So, a first one that we talked a lot about today is the complexity of it. It's not like it's just a, hey, we just need this one new technology or one new resin and everything can be recyclable. So it is complex, and that's why it's so important that we get feedback about the challenges and the issues and have the opportunity to try to figure out the right solutions. The second one is cost. And I mentioned this earlier that we're at the early part of optimizing these recyclable films. I mean, I would say we're maybe in like a Gen 2 or a Gen 3 from a development and getting them optimized for the end uses and the processes that have to be able to turn them into a package or even make a film. So our goal is to figure out whether it's through down gauging or higher performant resins, like how do we get those to cost parity? It's a ongoing process. I think it's achievable, but not until we get to some scale, both from capacity with MDO and BOPE, but then also with some critical mass of having some of these big categories on the, for food packaging convert to recyclable films to just make the economics be more reasonable. And I think it would be unfair to not mention that collection is an issue where, why am I going to design my package to be recyclable if it's not going to be collected? So I think that also feeds into the fact that anything that's clean and dry, the examples that Eduardo shared, those can be collected by store drop off. If you've got a meat package that has blood on it, those grocery stores, first of all, don't want those in the front of their facilities. And I'm glad that they don't. It could cause smells and other issues. And then sometimes those contaminants on the film can cause a problem in the recycling of those. So might degrade the quality of the PCR. So we are working hard on that. The collection piece, like Dow made an announcement with WM, who's waste management, who has, I think they estimate that they have like a 50% of the waste collection market. So we need to work and address that. If I had to estimate, my crystal ball about when curbside will be available widely, I mean, that's 10 to 15 years away. And honestly, it's tied very closely with the EPR and the legislation where we need the EPR funds to be invested in the collection and sortation and the other pieces that we know are so important. So it's a little bit of a chicken and egg right now, but I would say cost, complexity, and collection are the top. And then I would be remiss not to mention consumer behavior. How do we convince consumers that it's worth their time and energy to maybe sort things when there's curbside, or again, take things to the store, drop off it as a, hey, I can keep this out of the landfill today. Maybe it's not every single plastic package, but at least I can do my part to protect the environment.
Excellent. Eduardo, anything else to add, or should we go on?
No, I think, Michelle covered very broadly, and she mentioned about the consumer education, very important. So we need to really have education on, on recyclability and take the extra effort to, and I mean, we, as part of the industry, do that. I mean, go to the supermarket, drop your, what can be recyclable, recycle it. So that's what we've been doing.
Okay, great. We've got a few more minutes. I'm going to try to field a couple more questions that we have, and we'll wrap this up. So the next question is, when running a mono material film on my line, what are some considerations or changes I should make to optimize the machinability?
Yeah, I think here what's important, you need to check what is the film technology, the ideal film technology, correct? I mean, we talk about the barrier, etc., but then you need to make sure you're working with the film that can deliver the performance and the best machinability using all the technologies that have been developed. On the machine side, machine side, I mean, there are machines out there that have been working, they were developed, optimized to work with both multi-material or mono-material. But if you have eventually a machine that is relatively old and is not capable to run, so the suggestion here is really to, like we listed, talk to your film supplier, talk to your machine supplier, the OEM, packaging OEM, and a lot of them are, like I said, they've been working on and to develop this technology. So they have, some of them you'll be able to do retrofit. So I think you have to do a cost assessment on retrofitting the line. And I think I have heard from many packaging OEMs, they've been working a lot on this. They've been getting a lot of requests, and we've been working in projects with some brand owners where we are, the OEM is making an assessment on the line. They can do some trials with the films, and then they can define what kind of retrofitting is eventually you need to do in the line to be able to run the mono material at the speeds and productivity that make it cost effective. And that's where the industry engaged to do the support. My recommendation, reach out to your film supplier, reach out to your packaging OEM, reach out to us, for example. So I think the value chain is really working together to make sure we deliver the performance that is needed for the mono material.
Michelle, anything you'd like to add, or are we good on that?
No, I'm good. Eduardo's the expert on those kinds of details.
Okay, perfect. Okay, next question. Are monomaterials and recycle-ready films viable for liquid product formulations such as shampoos, conditioners, gels, lotions, oils, serums, or household cleaners with solvents in the formula?
So this is a great question. I'm going to answer it with the classic, it depends. So so depending on the incumbent structure and the performance requirements, it's probably technically feasible to come up with a monomaterial alternative that would meet the barrier requirements and other requirements. This is where it gets hard, is the contamination that you're mentioning. And so just an example, we're working with SPC again. So SPC is the one who decides if a package can go into the store drop off or if it needs to be recycled and collected in another way. So we're working with SPC to try to get better at defining what is acceptable product contamination on a film and what's not. So things like, pet food would have grease. I mentioned meat might have blood. And in your case, you're saying like there could be solvents or things left in based on the formulation of the product. So that's evolving. I can't give you a definitive yes or no because it depends on what specifically is left over and then how much is left. But I can tell you that we are trying to establish, work with SPC to establish a more rigorous, I won't say rigorous, more quantifiable way to decide is it acceptable or not. But great question.
Yeah, I want to add here, Michelle, that you covered that mechanical recycling is not the only solution for the whole, for the recyclability. So designing for recyclability and going for monomaterials, like for applications that today cannot go to a store drop-off, this is beneficial for the advanced recycling. So the polyolefins-based films are more preferred for advanced recycling. So that's why I would say the reason for us, for you, if you're not today, cannot, because of the content of the packaging, cannot go to the store drop-off, but you're preparing this packaging to be accepted for the advanced recycling. That's also important. So
that's a great point. I just will say that we don't see mechanical recycling or advanced recycling. We feel that they are both needed. They're complementary to each other. And exactly to Eduardo's point, if you can't comply with mechanical recycling requirements, then that's where advanced recycling or other new technologies are going to come in to fill that gap. Great question.
Excellent. Let's try to squeeze in one more question. We're close to time, but one more quick one if we can. Can you share more about the capabilities at PAC Studios that can help with optimizing of monomaterial films?
Yeah, I'll just quickly use like the mess pack line as an example. We've got the mess pack line that is a stand-up pouch line that we have the ability to, have the updated triple point seal bars, so that we can kind of test like, well, how do you run this film without the upgraded seal bars, and how, what is the implications of switching and upgrading to the new seal bars. And we can do that all in house and understand how to optimize the films to run in either case. Eduardo, what else do you want to add?
Yeah, I mean, also add beyond all the capabilities we have in house. I mean, we work very close with the packaging OEMs as well. So, and if we don't have the capabilities, we try to work with our partners in the industry to validate, monomaterial. So I think it's a combination using our capabilities and also the partnership with the packaging OEMs and the value chain.
Excellent. Thank you so much. Once again, Eduardo and Michelle, thank you so much for your time. You provided us a tremendous amount of valuable information. Thank you to Dow for affording you the time to do this and supporting this initiative with our association. It's very much appreciated. To the audience, thank you for attending. This webinar gives you a great insight to some of the educational topics that we present at Engage. Once again, Engage is our annual meeting held in February. In 2025, it'll be in Clearwater, Florida from February 4th to February 6th. More information is available on the contractpackaging.org website. This is the premier annual gathering for our industry, so it's a must attend. On behalf of the CPA, thank you for attending. Have a great day.